Hey guys, welcome to Lab 3. This one's on how to make a standard curve using a spectrophotometer. Now, you've already done 2 labs where you've graphed, so hopefully you're starting to get the hang of graphing. Graphing is going to be very important in this lab and the next one and at least a couple more. So let's first start off by looking at what we're going to be doing. Okay, today we're going to be using a spectrophotometer to determine the concentration of cobalt chloride in a solution. Now, the way a spectrophotometer works is that it passes light of a specific wavelength through a chamber, and we look at how much light makes it through. What we're looking for is transmittance and absorbance. Transmittance is how much light got through, absorbance is how much was absorbed. The more strongly the material in the tube reacts with that wavelength of light, the less of it gets through, the more is absorbed. So the first thing that we've got to do is determine which wavelength of light works best with our cobalt chloride solution. Now, our cobalt chloride solution, okay, is pink. See? Pretty pink color. So, what we're going to do is we're going to start out with a 0.2 molar cobalt chloride solution, and we are going to observe wavelengths and transmittance. Now, here's a diagram of a spectrophotometer. The knob on the left we use to turn it on and to set the 0 point when nothing is in the chamber, 0 transmittance. Then we put a tube of distilled water in there, and we use the 100% transmittance to tell the machine what it looks like when 100% of the light goes through. This sets the wavelength, and then this button controls whether we're reading transmittance, absorbance, and a couple other things we won't pay attention to. Okay? So, let's start looking at the spectrophotometer. So here's the spectrophotometer. Okay? Whee, the real thing. All right, now, right now, there is nothing in the chamber. See? Empty. With that closed, I'm going to use this knob to set the 0. So I want that to read 0. Okay, now we're going to put a tube of just distilled water in there. That's plenty. Push it all the way down. Close the lid. Now we want this to read 100. So I'm going to turn the knob here until this reads 100. Boy, somebody got this cranked way down. Oh, hold on. A knob was flipped. So let's get this down to 100. I was like, boy, that was way off. Okay. Okay, now the machine is referred to as calibrated. It knows what 0 and it knows what 100 should look like. Okay? So, let me set this back just a little bit. Oh, there's a nice glare. Okay, I'll put the glare over there. All right, guys. So I'm going to adjust that just a little bit. It drifted a little on me. Okay, now I'm going to take the distilled water out, and I'm going to put 0.2 solution in. So we're going to need the distilled water over and over again. So we'll need a test tube rack to hold it. Okay, guys, now here's my 0.2 solution. I'm putting it in. Notice there's a line on the tube. There's also a little raised piece right here. I'm lining it up and I'm sliding it in, closing the lid. Okay, now I'm going to read the transmittance, and it's reading 27.6. So we're going to record that, 27.6. 450, 27.6. Now I'm going to take that tube out, and I'm going to change the wavelength to 460. Okay? Make sure that that's reading 0. Pop in the distilled water. And check the 100. Okay, take the 100 tube out, put in our 0.2 cobalt solution, and record the transmittance, 19.8. And then we just keep moving on. Now what we're looking for is the wavelength that's going to interact most strongly with our cobalt solution. And when we reach that wavelength, what we'll see is that the transmittance kind of hits the low, and when I go past it, the transmittance starts to climb again. So I'm just going to keep bumping it up. Wavelength, this is 470, and I'm going to recalibrate every time for every wavelength, and we're going to record the transmittance. Okay. So at 470, it's 13.8. Now I'm going to go to 480. Okay, still reading 0. Usually your 0 holds pretty constant, but you always have to keep recalibrating for the 100%. Okay, at 480, we're at 10.8. Changed it to 490. Overdid it. At 490, we're at 9.6. Notice how it's been steadily going down. We go to 500. Oop, I've done my zero. Is my 0 okay? Yeah, zero's okay. Now I set my 100% transmittance. Okay. I'm at 7.4. Now we go to 510. Reset the 100. .8. You go to 520. Okay, I reset the 100% transmittance. Remember, that's important every time I change wavelength. I have to recalibrate. Now we've gone up to 8.2. So we've hit our bottom point of transmittance and we're starting to go up. Our bottom point was at 510. So I'm going to reset my machine to 510 and I'm going to run the rest of the experiment with 510 because that's the wavelength of light that interacts most strongly with my cobalt solution. Now, I've got to recalibrate it because I went up to 520, so I have to take it back to 510 and recalibrate so I have my machine ready to go. Okay? Now what we're going to do is we're going to take a series of standard solutions and measure their absorbance at 510. Okay? Our first solution is our 0.20 molar. So I'm going to pop this in and I'm going to hit the button here and I'm going to change it to absorbance. So the absorbance for our 0.20 is 1.180. Okay? Now we're going to move to a lower concentration solution. Our next solution is 0.175 molar. All we have to do is pop it in. Okay? And it's 0.890. All right, we'll move on to our next solution, which will be 0.150. And the absorbance is 0.792. Our next one is 0.1250. 0.1250, and our absorbance is 0.648. Okay, now we have 4 data points, which is plenty to make a graph. So those are all our known solutions. Now we're going to do a couple of unknowns. Okay, We're going to measure them at the same wavelength. Unknown number 1. Pop it in. And I get 0.694. No, 0.692 now that it's settled. Okay. Unknown number 2. Is 0.910. We have an unknown number 3 or just 1 and 2? I think we may only have unknowns 1 and 2. Okay, we're going to do an unknown number 3. And your last unknown, unknown number 3. 0.940. Okay? So we have collected all of our data. And we're done collecting data, and now it's just a matter of processing our data. So let's go back to looking at our screen here. I'm going to talk about processing data. I know the screen has gone all Shelton State on you, but don't panic. Okay, guys, now, this is the table that you've just filled in, and I'm going to put only unknown 1 and unknown 2 here before I load this up for you guys to fill in. I'll put unknown 3. You're going to be doing an Excel graph. Okay? So let me show you the Excel graph that you're going to do. Now, so you're going to go 0.2000, 0.175, 0.150, and 0.125. Those are your 3 points. And then you're going to write absorbances in here. Okay, I'm not going to do the ones that you just got because I'm not going to do the graph for you. So let's say I've got an absorbance here of 1, and then here of 0.8, and here 0.71, and here 0.63. Okay? I'm going to highlight those, go to Insert, and then I'm going to go to XY Scatter and have it plotted. Right-click on one of the dots, have it add trend line, and display the trend line on the equation. Let me pull this up. Now, we've got our Y. The very important thing on this graph is your equation. Okay? Y is your dependent variable. That's your that's your absorbance. X is your independent variable. That was your concentration. So Y is absorbance, X is concentration in this equation. Now, you have absorbances for unknowns. So what you would do is the following. Okay? Let's look over here. I'm going to show you an example. So let's say unknown number 1 had an absorbance equal to 1.07. Okay, remember this is an example. This is not your real data. So I would have my equation y equals 4.8x plus 0.005, and I go 1.07 is equal to 4.8x plus 0.005, and I'm going to solve for x. So 1.07 minus 0.005 divided by 4.8 would tell me that my x was 0.222 molar. So that would be my concentration of cobalt in unknown number 1. So do your graph. Okay? Hello? Sorry about that disturbance, guys, but I had to take a call. Okay, so when you send this back to me, I want your data sheet, I want the equation here on this line, I want the concentration of unknown number 1, unknown number 2, and unknown number 3. I'm going to go in and modify this before I put it up for you to fill in. And I want a copy of your graph. Okay? You can just, this is a Word document. You can cut and paste it into the end of your Word document and then just email me the Word document. All right? So, lab number 3, ready for you to do.